Okay. Before we move to a new topic, we will do one more example, that of electron scattering. So, E minus plus E minus going to E minus plus E minus, and then we will compute the differential scattering cross section for this process. You already know the S matrix to lowest order, which gives a contribution is given by I 2 pi to the power 4th delta of P1 prime plus P2 prime minus P1 minus P2 times the Feynman amplitude m. There are two diagrams which contribute to this process at lowest order, and these two diagrams are given by two incoming electrons of momenta P1 and P2, and then the outgoing electron of momenta P1 prime, P2 prime. The exchange of virtual photon whose momentum is given by P1 minus P1 prime. The other diagram is obtained from this one by exchanging these two outgoing electrons. So, this is the diagram for the second process. Here you have an incoming electron of momentum P1, P2, but this one has energy momentum P2 prime and this one has energy momentum P1 prime. So, the virtual photon carries energy momentum which is given by Q equal to P1 minus P2 prime. We can use the Feynman rules to write down the amplitudes for these two processes, and then we will add the amplitude, keeping in mind that there is a relative minus sign we have to use because of the exchange interaction. So, the amplitude, the Feynman amplitude for this process ultimately is given by, here I will start from this one. You have this incoming electron U s of P2, then there is this vertex which is I e gamma mu, and then you have this outgoing electron which I will write U bar S prime of P2 prime. Then you have a propagator, photon propagator. So, for a photon propagator I write eta mu nu divided by Q square, which is P1 minus P1 prime square, and then I have an incoming electron for which I will write U r of P1. Then I have a vortex for which I will write I e gamma nu, and I have an outgoing electron for which I will write U bar r prime of P1 prime. The second one is just obtained from the first one just by exchanging P1 prime and P2 prime. So, the amplitude for the second one is with a minus sign. I will just write U bar r of P2 prime r prime I e gamma nu U r of P1 eta mu nu divided by P1 minus P2 prime whole square, and U bar S prime of P1 prime I e gamma mu U S of P2. All right. So what we have to do now is we have to just consider the differential scattering cross section, formula for the differential scattering cross section, and then substitute this for the Feynman amplitude, and then simplify the formula to get the final answer. So what is the differential scattering cross section when you have two incoming fermion and two outgoing fermion? The differential scattering cross section is given by d sigma. You have to remember the phase factor, integration measure, etc. we are taking differently for fermions. So for fermions this is m square divided by P1 dot P2 whole square minus m fourth to the power half, okay, and then you have 2 pi to the power fourth delta P1 prime plus P2 prime minus P1 minus P2 mod m square, then I will have dq P1 prime over 2 pi q m over E1 prime, then dq P2 prime over 2 pi q m over E2 prime. This is what is the differential scattering cross section. Again I will just integrate out this delta function, and finally I will get d sigma over d omega. So all one needs to do is to compute the mod m square, and then you already know how to integrate out the delta function. You compute the mod square, you plug it in this formula, and then you will get the final answer. You have to keep in mind that the energy momentum conservation holds. Okay, so let's do that. What we will do is that we will now work in the center of mass frame. So in the center of mass frame, the total momentum P1 plus P2 is equal to 0, and so is P1 prime plus P2 prime. So you have the electrons, there are two incoming electrons with momenta P1 and P2 equal and opposite magnitude, and then there are two outgoing electrons P1 prime, P2 prime. The scattering angle is given by theta. So therefore the 4 vector P1 mu is basically E, which is P1 0, and I will call this P1 to be P, I will denote this to be P, then my P2 will be minus P. So you have this P2 is equal to P2 mu is again E minus P. Similarly, you have P1 prime mu is simply E P1 prime or I will denote this to be P prime, and P2 prime mu equal to E minus P prime. So I will use I will do the entire calculation in the center of mass frame, where the 4 moment I have this form, and then I will evaluate mod square of this matrix element. P1 lower mu is this, okay. Why is it so? So again what we will do is that we will sum over the polarization of outgoing electron and average over the polarizations of the incoming electrons. So I have what I will call as m square average is simply sum over r s r prime s prime mod m square, and what is the factor I will put? 1/4, because there are 2 incoming electrons. This is what I need to do. So let's do it. So this is 1/4. Now there is an E fourth, because there is this E square here, mod square, and finally what I have is U r prime bar P1 prime gamma nu U r P1 U s prime bar P2 prime gamma nu U s P2. I have used this eta mu nu to contract one of these gamma matrices. This divided by P1 minus P1 prime square, and then minus the same thing, but P1 prime and P2 prime are exchanged. So U bar r prime P2 prime gamma nu U r P1 U bar s prime P1 prime gamma nu U s P2 divided by P1 minus P2 prime whole square, this mod square. This is what we need to evaluate. Again I will get 4 terms, but you will see that we need to evaluate only 2 of the 4 terms. The remaining 2 we can just obtain by exchanging P1 prime and P2 prime. So the first term in this expression is 1/4 E fourth times okay. So what I will do is I will just, instead of writing it and then deriving the trace, what we will do is that we will consider mod square of this term and then see if we can simplify that. And finally, we will look at the cross term and the remaining cross term, and then the mod square of this will be obtained by exchanging P1 prime and P2 prime. So, the first term in this expression is forget about the 1/4 a fourth term, we will take care of it later. There is a summation over r and s, yeah, good, r s r prime s prime. So, first term is sum over r s r prime s prime, and then there is a 1/p1 minus p1 prime whole fourth and mod square of this u bar r prime p1 prime gamma nu u r p1 u bar s prime p2 prime gamma nu u s p2 mod square. We need to evaluate this, but you keep in mind that this gamma nu here is a dummy index which is repeated. This is a number and this is also a number. So, this is just you cannot simply, so the whole mod square is just mod square of this times mod square of this, but all you have to keep in mind is that in the first term you have while evaluating the mod square you have to use a different dummy index for the second one. Or what I am saying is, if you look at u bar r prime p1 prime gamma nu u r p1 u bar s prime p2 prime gamma nu u s p2 mod square. By this what I mean is u bar r prime p1 prime gamma nu u r p1 conjugate, because this is a number, and then u bar r prime p1 prime gamma mu instead of gamma nu u r p1 this, and similarly the second term will give u bar s prime p2 prime gamma nu u s p2 conjugate of this, and u bar s prime p2 prime gamma mu u s p2. All right. This is what you are doing. So, I am using gamma nu, the index, I am labeling the index nu for the complex conjugate of this and using the label mu for the term itself, and then I am just rearranging them. Now, what I need to do is I need to consider this and sum over r s r prime s prime. So, here again I have to sum over all the spin indices r s r prime s prime. You look at this only involves r and r prime, the first two terms, and the second two terms involve only s and s prime, and then we know what this is. We have already done this when we worked out the competence scattering. So, what you get when you carry out the spin sum in this term is simply, so if you just consider the first two terms, this will give you trace of gamma nu and P1 slash plus m divided by 2 m, then gamma mu bar P1 prime slash plus m divided by 2 m. This is what you will get from the first two terms, and similarly you will get exactly the same expression from the second two terms. So, the whole thing is going to be the product of two traces, one is this and then the one is again trace of the same thing, but the mu and nu indices are contracted properly. So, this is gamma nu P1 slash plus m divided by 2 m, gamma mu bar P1 prime slash plus m divided by 2 m. But gamma mu bar, according to our definition, O bar is just gamma 0, O dagger gamma 0. Therefore, gamma mu bar is gamma 0, gamma mu dagger gamma 0, which is nothing but, if you use the expression for gamma mu dagger, it is gamma 0 square, gamma mu gamma 0 square. So, this is simply gamma mu. Gamma mu bar is gamma mu, therefore, I will just simply remove the bar here as well as from here. So, this is what we will get when we sum over the spin indices. Now, all we need to do is we need to evaluate the trace and then we have to plug it in to get the first term. So, this is of course, the evaluating the trace is very easy because this involves only 4 gamma matrices. So, let us do that. So, what I will do is that I will just look at the first term here and then the second term will have a similar expression. So, the first part involves evaluating trace of gamma nu P1 slash plus m, gamma mu P1 prime slash plus m. So, this will have four terms, but two of them will have 3 gamma matrices whose trace will vanish identically. So, the remaining 2 terms are trace of gamma nu P1 slash gamma mu P1 prime slash plus m square trace of gamma nu gamma mu. So, this is what we have in the first part. This one is simply P1 alpha P1 prime beta times trace of gamma nu gamma alpha gamma mu gamma beta, and here this is plus 4 m square eta mu nu, because trace of gamma mu gamma nu is 4 times eta mu nu. Now, we have evaluated this trace in the last lecture. This is simply given by trace of gamma mu gamma alpha gamma nu gamma beta is simply 4 eta mu alpha eta mu beta minus 4 eta mu nu eta alpha beta plus 4 eta mu beta eta mu alpha. this is the trace. Now, what I have to do is I have to consider this and multiply it with P 1 alpha, P 1 prime beta. So, P 1 alpha, P 1 prime beta, that will give me 4, the overall factor of 4, I will just take it out. First one will be P 1 nu, P 1 prime nu minus eta mu nu times P 1 dot P 1 prime, and this term plus P 1 nu P 1 prime mu. Okay. So, this is what I get for this term here. Now, I have to add 4 m square eta mu nu here to get the first part. So, when I do that, I get the first part to be equal to 4 P 1 mu P 1 prime nu minus, I will write it first, P 1 nu P 1 prime mu minus eta mu nu P 1 dot P 1 prime, and then finally plus eta mu nu times m square. So, the first part gives us this, the second part gives us this, the same term, except that the mu and nu are, the indices mu and nu are contracted appropriately. Therefore, this quantity here will be, there are 2 m to the power 4th, okay, 1 over 2 m to the power 4th, and then so let us do that. When I substitute that for the first part, what I get here is 1 over 2 m to the power 4th, and then there are 4 square, 2 factors of 4, and this quantity is P 1 mu P 1 prime nu plus P 1 nu P 1 prime mu minus eta mu nu P 1 dot P 1 prime plus eta mu nu m square, that is from this part, and then from this part again I will get an identical term. Second trace has P2. Okay, good, thank you. So, this is P2 and P2 prime. So, all I will get is P2 mu. So, the mu and nu are now covariant indices, and P, instead of P1 prime, I will get P2 prime, P2 prime nu plus P2 nu P2 prime mu minus eta mu nu P2 dot P2 prime plus eta mu nu m square. All right. So, good. So, now what I have to do is that I have to carry out, I have to multiply all these terms, and then I have to simplify them. So, let us do that. So, this is equal to 1 over 2 m to the power 4th, and this is 16. The first term will give me p 1 dot p 2 p 1 prime dot p 2 prime. So, p 1 dot p 2 p 1 prime dot p 2 prime, and then I will get p 1 dot p 2 prime and p 1 prime dot p 2, then I have to multiply this minus p 1 dot p 1 prime p 2 dot p 2 prime plus m square p 1 dot p 1 prime. That is for the first term, and then there are 3 more. So, the second term will give me p 1 dot p 2 prime plus p 1 dot p 2 prime times p 1 prime dot p 2 and p 1 dot p 2 p 1 prime dot p 2 prime. Now, that will multiply to the third, which will give me p 1 dot p 1 prime with a minus p 2 dot p 2 prime, and finally, I will again get plus m square p 1 dot p 1 prime. So, again the or in other words, you could have simply concluded it that this term multiplied by this is identical to this term multiplied by this, because this is symmetric under the exchange of mu and nu, and hence they will just add up. Anyway, so then I have to multiply eta mu nu with the last term. So, this will give me minus p 1 dot p 1 prime times eta mu nu will give me p 2 dot p 2 prime with a factor of 2, twice p 2 then minus plus eta mu nu. What is this? It is 4. Okay, 4 p 1 dot p 1 prime p 2 dot p 2 prime. Then minus 4 m square p 1 dot p 1 prime. Finally, the last term multiplied to the second part, which is plus twice m square p 2 dot p 2 prime minus 4 m square p 2 dot p 2 prime plus 4 m fourth. That is all you have. Okay. So, So, now you see that some of the terms will cancel here and some of them will add up. For example, P 1 dot P 1 prime this and this will add up, and this will add up. None of these terms cancel, 2m square, this and this they will just cancel, and then these two will cancel, and then you will get a factor of 4. So, what I will do is that I will just write down the answer for you, 2m to the power 4 times 32 P1 dot P2 P1 prime dot P2 prime plus P1 dot P2 prime P1 prime dot P2 minus m square P1 dot P1 prime minus m square P2 dot P2 prime plus 2m fourth. I have taken a factor of 2, overall factor of 2. So, this gives me 2m fourth. This term and this term will give me this, adding these 3 terms will give me this. Similarly, you have this that will give me this one, and adding this P1 dot P2 prime will give me this one. Finally, what is left is this they will just cancel. All right. So, there is this factor of 2 here, there are 4 minus, and then they just cancel. So, these two add to give you this, these two add to give you this, and then you have these two to give this, these 3. All right. So, this is what you get for the trace. Now, what I will do is that I am using the fact that the energy momentum is conserved. So, P1 plus P2 is just equal to P1 prime plus P2 prime. This implies a number of things. First of all, this implies P1 dot P2 is equal to P1 prime dot P2 prime. This also implies P1 dot P1 prime is equal to P2 dot P2 prime. So, I will use these two relations here. Okay. You just square it, and then you remember that P1 square P2 square both are equal to m square, that will give you this relation. If you write this identity as P1 minus P1 prime equal to P2 prime minus P2, and then if you square now, you will get this identity. Now, I will substitute it here. Okay. So, when I substitute this here, what I get is the following. This simply becomes 1 over 2m to the power 4th 32 times P1 dot P2 whole square. Similarly, these two are equal. So, what I will get is P1 dot P2 prime whole square, and these two will add up minus twice m square P1 dot P1 prime plus twice m fourth. Now, what I claim is the following. I will just combine these two terms and then write it in a simpler fashion. So minus twice m square p1 dot p1 prime plus twice m fourth is simply equal to twice m square into m square minus p1 dot p1 prime, which is nothing but m square. I will write it as p1 square. Therefore, this is twice m square p1 dot p1 minus p1 prime. All right. Then what I will use, sir? I will use the energy momentum conservation rule to write it as twice m square p1 dot p1 minus p1 prime is equal to p2 prime minus p2. So this is just twice m square p1 dot p2 prime minus p1 dot p2. I will substitute this here, then what I get is this is equal to 1 over 2 m fourth 32 times p1 dot p2 square plus p1 dot p2 prime square minus twice m square p1 dot p1 prime plus twice m square p1 dot p2 prime minus twice m square p1 dot p2. All right. Now, what you see here from the last three terms, you just write, you can add them and then here. Okay, I wrote it twice, right? Okay. So that's the problem. Okay, thank you. So plus twice m square p1 dot p2 prime minus twice m square p1 dot p2. That's all I get for the first term in the trace. So now what I have to do is I have to evaluate one of the cross terms, okay, and then the remaining two terms in the mod square of the matrix elements I will just obtain by exchanging p1 prime and p2 prime. Okay, so then finally we will put everything in the formula for the differential scattering cross section and then obtain the scattering cross section for electron scattering. All right, so this we will do in the next lecture.